Switch it up, got me watching you. Switch it up, I like the things you do. Switch it up, always something new. Never stop, switch it up any way you want to.
Alright, so we're going to switch some things up in this lesson. We're going to talk about reciprocal trig graphs. Remember, that's when we kind of switch our cosine, sine, and tangent to make them either secant, cosecant, or cotangent. So when we, before we dive into these reciprocal trig graphs, when we switch things up a bit, let's just recall what the original cosine, sine, and tangent graphs look like. Okay, so a cosine always starts with that max. Hopefully we remember that. And especially when we're graphing these trig functions, the period is kind of a big deal. Okay, how long does it take in order for this graph to complete one full cycle? So on a cosine graph, if we start with a max, how long is it going to take us to reach another maximum height? So in a regular cosine parent function graph, the period is 2 pi. Now sine does not start with a max, it actually starts at the origin. And if we were to imagine starting at the origin and traveling along our sine graph, it also is going to take us 2 pi to complete one full cycle. So we can say sine also has a period of 2 pi. Tangent, on the other hand, it starts at the origin just like a sine does, so we can make note of that. But the tangent graph has those asymptotes. So if you want to, you can think about drawing those in. And the period, though, for tangent is not 2 pi. Notice how it kind of takes us from negative pi over 2 to a positive pi over 2 to complete one of these cycles. So that particular distance overall is a distance of pi. So that's really the only difference with the tangent graph. Aside from the asymptotes, it does have a period of pi, whereas cosine and sine have a period of 2 pi. Alright, so let's go ahead and take a look at these reciprocal trig graphs. Our first reciprocal function we're going to talk about is secant, and we know that secant is the reciprocal of cosine, or in other words, 1 over cosine. So we can anticipate this secant graph to look very similar to the cosine graph because they are reciprocals of each other, and that's actually what we're going to do. We're going to start with this cosine graph and kind of analyze it, find the reciprocal of it to see what the secant graph actually looks like. So if we were to rewrite secant as 1 over cosine, notice how we're dealing with a fraction. And particularly when we're talking about graphs, we know a fraction, or at least the denominator, cannot equal 0. Now, graphically speaking, the numbers or values that make the denominator 0 would give us a vertical asymptote. So let's take a look at our original cosine graph and find some values where the graph is 0. It looks like we have a 0 at negative 3 pi over 2, negative pi over 2, a positive pi over 2, and a positive 3 pi over 2. So if those are the points on the cosine graph that equals 0, these are the points on our secant graph where we're going to have a vertical asymptote, because after all, these are the numbers that wouldn't work. These are the ones that make our denominator 0. So let's go ahead on our graph and draw in vertical asymptotes at those values. So on a secant graphs are going to have asymptotes just like a tangent graph has asymptotes, but they're specifically found at these values because these are the zeros of a cosine graph. Now let's take a focus on the maxes and mins. Okay, so here's a max, there's a min, there's another max, there's another min, there's another max. So let's just go ahead and plot those on our graph. So a cosine has a max at 1. It also has a min at negative 1. And if we were to fill in the other ones, it would look something like this. Again, we're basing our secant graph off of the cosine graph because they are reciprocals of each other. Now here's where the idea of a reciprocal comes into play. Notice how this section right here, okay, we start with our max, and on either side of that max, our graph is going down. But on a secant graph, since it's the reciprocal, if we were to flip this image of it going down, that now means if we were to flip it, it should be going up. So from this max, instead of traveling downwards like the cosine graph does, we want to flip it to travel upwards, because after all, we're looking at the reciprocal. We're looking at that secant graph. So let's kind of move on to maybe this image right here. Notice how we're starting at this min, and on the cosine graph it goes up from that minimum value, but that means on our secant graph rather, instead of going up, we are dealing with the reciprocal, so it should be going down. Now keep in mind we cannot go past those vertical asymptotes, so it's kind of trapped in between those. So let's just kind of fill in the rest of our graph. If this is a max, instead of traveling down like it would on a cosine graph, the secant graph will be traveling upward, and you can imagine another one going over here if we were to continue our graph. If this is a min, it will be traveling downwards, just like this one did, and if this is a max, it will be traveling upwards. Alright, now let's check out the period of this secant graph. So this right here is what a secant graph looks like. Very related to cosine, but since it's the reciprocal, instead of traveling down or up in certain positions, we are switching it up because they are reciprocals. Now, if you notice between, I'm going to highlight this asymptote and this asymptote, we have this upward U-shape and then this downward U-shape. And notice how that pattern continues. We're going to have an upwards U-shape and later on we'll have a downwards U-shape. So from this asymptote to this one is considered one full period, because after all this distance will be repeated forever and ever to the right and forever and ever to the left. So from negative 2 pi to a positive 3 pi over 2, that is a total distance of 2 pi. And that should kind of make sense, because if the cosine graph has a period of 2 pi, just like we highlighted over here, the reciprocal graph, since it's related to cosine, should have the same period. So the secant graph in this case also has a period of 2 pi. Alright, so let's go ahead and do the same graphical analysis, but this time we're looking at cosecant, which is the reciprocal of sine. So we can rewrite cosecant as 1 over sine, which means in order to graph cosecant, we're going to base it off of our original sine graph. Now again, since we're dealing with a fraction, we know the bottom cannot equal 0. So let's take a look at where our original sine function equals 0, because that's where our vertical asymptotes would be for our cosecant graph. So if we were to highlight those, it looks like we have a 0 at negative 2 pi, negative pi, the origin, pi, and 2 pi. So if these are the zeros of sine, that means we have vertical asymptotes at those values. So let's go ahead and draw those in. These are the values that are not going to work in our fraction. They make our denominator equal 0. Alright, so now let's focus on those maxes and mins, just like we did for the cosine graph. And let's plot those points on here, min, and then a max. Alright, so if we were to analyze our graph, notice how our sine graph at this particular point, this maximum, travels down on either side. But since we're trying to find the reciprocal, okay, we're trying to find that cosecant graph, we need to flip this. It's a reciprocal where we flip the order. So instead of traveling down from that maximum, it will now be traveling up. Again, it's trapped between those asymptotes. You cannot touch them. In this section, if we have a min, the original sine graph travels up on both sides from that minimum, but on the reciprocal, that means it will be traveling down. And if we were to continue the pattern, notice how it's going to repeat itself. So it should look something like this. Now again, we can analyze the period of our cosecant graph. Okay, so maybe we'll look at this asymptote at the origin and this asymptote at 2 pi. Notice how we have an upward U and then a downward U, and this same process, this same image is repeated forever to the left and forever to the right. So from 0 to 2 pi, that's considered one full cycle, so that distance is 2 pi. Again, that makes sense because the original period of sine is 2 pi as well, so our reciprocal should have the same period. Alright, so last but not least, let's check out our cotangent graph. The reciprocal of cotangent is tangent, so cotangent we could say is equal to 1 over tangent. And just like sine and cosine, we want to figure out when does our tangent graph equal 0, because those are the values that are not going to work in this fraction. So let's go ahead and take a look at those. It looks like we have negative 2 pi, negative pi, 0, pi, and 2 pi. So at those values, we are going to have asymptotes. We can fill those in. Alright, so notice how when we have those zeros, we have those vertical asymptotes. But if we were to look at our original tangent graph, okay, this one had vertical asymptotes to begin with. So if we were to fill those in just as a visual, something kind of interesting is going on here. So whenever we had on our original tangent graph, whenever we had a 0, on the reciprocal we have that vertical asymptote. But whenever we have a vertical asymptote on our tangent, that's when we're actually going to have a 0. Okay, it's that whole idea of a reciprocal switching things up. If the original has a 0, it's a vertical asymptote on our reciprocal graph. But if our original has a vertical asymptote, that means we have a 0 on our reciprocal graph. So we should have a 0 at negative 3 pi over 2. We can put a little x-intercept right there. We should have an x-intercept at negative pi over 2. Same with positive pi over 2 and 3 pi over 2. Okay, so it's that opposite idea. If we have a 0 on the original, it's a vertical asymptote on the reciprocal, and if we have a vertical asymptote on the reciprocal, it is now a 0. Now here's the other thing, just like all of our other sine and cosine graphs, if we were to look at the original tangent graph, notice how it kind of travels upward from left to right. But on the reciprocal graph, we need to switch the order. So instead of traveling upwards from left to right, the reciprocal would be traveling downwards from left to right. So we can fill in that repeating pattern in all of our little sections. And again, if we were to kind of analyze the period of this cotangent graph, notice how from this asymptote to this one, we have our one image, and it's repeated forever to the right and forever to the left. So this is considered one full cycle from 0 to pi. That's a total distance of pi. And again, that makes sense because our tangent graph originally has a period of pi as well. So here's what you can do. Notice how we easily created these all these reciprocal graphs from the originals. So if you really understand the original cosine, sine, and tangent graphs, these are easily duplicated or repeated for the reciprocal graphs. Or, if you can't really analyze these to help you get the reciprocals, you can simply try to memorize what these reciprocal graphs look like. So secant and cosecant are very similar. Okay, notice how they're both having kind of those parabolas, but that's kind of self-explanatory because cosine and sine are also very similar as well. So you can either recreate these reciprocal graphs just based on your knowledge of the original sine, cosine, and tangent, or you can try to kind of remember what these look like at face value. Alright, so let's try to graph some of these reciprocal trig functions. And what's nice about these reciprocal trig functions is that we graph them the same exact way we've been graphing cosine, sine, and tangent, because after all, these are trig functions. We can graph them the same way as our original trig functions. So we still need to identify the amplitude, the period, if we have a vertical shift up and down, maybe a phase shift left and right. So we still need to identify those pieces. If we take a look at cosecant, it looks like our amplitude out front is 1. The period of cosecant, remember this originally has a period of 2 pi, but we have to divide it by a half in this case to find our new period, which would end up being 4 pi. We do not have a vertical shift because we're not adding anything or subtracting anything on the end, so we can say none. But we do have a phase shift that's moving left pi over 4 based on this value right here. Notice how the 1/2 was factored out. So this is telling us exactly which direction our graph is moving to the left. So just like all of our other trig functions, we're going to start with the original. Cosecant is the reciprocal of sine. So you can try to think about what the original sine graph looks like to help you graph the parent cosecant graph, or you might just want to remember what cosecant looks like. Cosecant has a vertical asymptote at the origin. So go ahead and draw that in. It has a minimum at pi over 2. And another vertical asymptote at pi, and the first piece kind of travels up like that. Now you could graph kind of the other U shape over here. You also could graph it on the left. I'm actually going to graph it on the left side over here. So I'm going to graph the other piece. Looks something like this. Right, so there's one full period of this cosecant graph. Notice how I included both pieces because this overall image will be repeated to the right or to the left. So right now I have one full original period of our cosecant graph. So we did not identify a reflection. We can cross that off. Let's go ahead and graph our period. So instead of taking up 2 pi like it currently does, it needs to take up 4 pi. So instead of this, notice how overall we take up 8 spaces, and that's 2 pi. So we're essentially doubling it to get to 4 pi, which means this this piece taking up 4 spaces now has to take up 8, and this space that's taking up 4 spaces, it currently has to take up 8 as well. Okay, we're doubling this distance. So let's double this asymptote from pi to 2 pi. So that vertical asymptote is going to move over here. And same with this one. If we double negative pi, it's going to be stretched over to negative 2 pi. And this guy is going to stay right in the middle, right on the y-axis. So notice how from our ending asymptote to our ending asymptote over here, that is a total distance of 4 pi. But again, everything is kind of evenly spaced from there. If this minimum was originally in between our black asymptotes, it now should be in between our red ones, which means this guy should be moved right here. And it's going to continue to travel upwards, but just now a little bit wider to reach those asymptotes. And if we were to do the same thing for this upside down U shape, it would look something like this. All right, so we can cross off our period. It now has a period of 4 pi. We do not have to move it up or down at all. We just need to move everything to the left, pi over 4. Now, if you notice on your original graph, pi over 4 is 1 tick mark, because 2 tick marks is pi over 2, and pi over 4 is half of that. So we only need to move the asymptotes and these points left 1 unit. So this asymptote, if we move it to the left 1, would be right here. This point, if we were to move it to the left 1, would be right here. And continuing that process, the asymptote would move to the left 1, the point would be moved to the left 1, and you could draw in another tick mark if you want somewhere off your graph. So let's just fill in the rest of our graph, and there is our cosecant graph. I kind of skipped the amplitude. It was a 1, so notice how it still has a height of 1 from that baseline, okay, that x-axis, and we said we didn't have to move it up or down at all, and we just moved it to the left or to the right. So this blue graph overall would be the final graph of this cosecant graph. All right, let's check out another one. This time we're dealing with secant, and hopefully little red flags are going off in your head right now that this inside piece is not factored. So let's go ahead and factor that so we can find our phase shift. So if we were to divide both pieces by 2, okay, factor out that 2, we'd be left with x minus pi over 2. And now that it's factored, let's go ahead and identify our different pieces. It should be worth noting that we have a reflection, so even though that's not listed as an option down here, you still should make note of that. There is a reflection, so we'll put a little check mark there to make sure we graph that. Our amplitude is 2. Our period for a secant graph is normally pi or 2 pi, but our b value is 2. So when we divide by 2 to find our new period, it's actually pi. A vertical shift, we're moving down 1 because of that guy right there. And our phase shift, we're moving to the right, pi over 2 from this guy right here. So we have a lot of stuff going on. Let's start with our original secant graph. Okay, so secant starts with a little minimum right there at the origin, but it has those vertical asymptotes at negative pi over 2 and positive pi over 2. So there's our first piece. Again, you can draw the second piece either to the right or to the left. I think I'm going to go ahead and draw it to the left, up to you. Now the reason I'm picking the one to the left is because I noticed this guy right here. I'm eventually moving everything to the right. So I'm going to start with the most pieces I can on the left. That way when I move it to the right, I still have enough graph. So that's just my reasoning, but again, it doesn't matter which one you pick. So there's my original secant graph. This is considered 1 period. Okay, notice how that's a distance of 2 pi. So we're going to focus on this image right here. So let's start with our reflection. Okay, that just means we're flipping our images. The asymptotes are still going to remain the same, but if I flip the image, it's no longer a U going down. This one will have to be going up. And this U that's going up, if I flip it over, will now be going down. So there's our reflection. Now let's check out our period. Instead of traveling a distance of 2 pi, now we have to shrink it down to 1 pi. So we're essentially cutting everything in half. So instead of having this asymptote at pi over 2, we need to cut that in half, which would shrink it down to pi over 4. So this asymptote is going to move to pi over 4. And if we were to check out this asymptote at negative pi over 2, if we cut that in half, it's now going to be at negative pi over 4. And notice how this distance is only 2 units long, 2 blocks long, so we can anticipate the other piece to only be 2 blocks long as well. The other asymptote at negative 3 pi over 2 would be shrunk down here to represent those 2 blocks. So our red graph, after we graphed our reflection, should only be spaced in between those 2 new asymptotes. And same thing here, spaced in between our 2 new asymptotes. So there's our period. Again, you might want to erase as you go. I'm going to be using a lot of colors here, but you can erase as you go if you're using a pencil. Now let's try our amplitude. Instead of having a height of 1, it now needs to have a height of 2. So let's go ahead and show that transformation. And same with this one, instead of having a height of 1, it now needs a height of 2. So we'll cross that off. Kind of running out of colors here. Let's move everything down 1. So the green dot moving down 1 would be on top of our previously blue one. And this green one moved down 1 is now down here. Alright, so just as a little heads up, our asymptotes are still the blue ones. We haven't really moved anything left or right at all, but we are about to because we are on our last transformation. So let's cross off the up and down, and we'll finally move on to the right motion of pi over 2. So if you take a look at your original coordinate system here, pi over 2 was considered to be 2 units. So let's shift our yellow graph to the right 2 units. That means absolutely everything, the asymptotes as well as our curves. So the yellow asymptote moved 2 to the right, would be somewhere right here. The yellow dot moved 2 to the right, somewhere right there. And this yellow asymptote, 2 to the right, would be somewhere right there. So we can fill in that shape and move on to the next one. This dot moved 2 to the right, somewhere right there. And the yellow asymptote moved 2 to the right, somewhere right there. And then filling in our shape. There we go. Now since this is our final graph, let's go ahead and fill in the rest of our graph over here. This orange piece is going to repeat itself. So this U shape that we have will now be over here if we were to fill in another portion. And then this upside down U would be somewhere over here, again, if we were to fill in another portion. And we can slightly fill in a little bit more based on our graph. You could go more to the left if you want to. If you were one of those erasers, you can fill in the rest of your graph to the left. I'm not going to because we have a lot of other colors going on, but the orange one is the one that would be repeating itself. So moving on to number 3, let's go ahead and take a stab at a cotangent graph. Again, hopefully light bulbs are going off for this one that we need to factor out this 1/2. So if we were to do that, we would have 1/2 and then the inside quantity, essentially dividing all these pieces by 1/2 since we're factoring it out, would leave us with x plus pi over 4. So pi over 8 divided by 1/2 would eventually leave us with a pi over 4. So let's go ahead and focus on this factored cotangent equation for us to analyze these different pieces. Amplitude of 1 period. Now here's the thing to remember, the original period of a cotangent graph is pi, not 2 pi. So we got to take pi divided by 1/2, which would give us a new period of 2 pi. We have a vertical shift nowhere because we're not adding or subtracting anything on the ends, but we do have a phase shift left, pi over 4. So let's go ahead and start with our original. Cotangent has a vertical asymptote at the origin, and then another one at pi over 2. No, I'm sorry. At pi, my bad. We're going to erase that. At pi. And the 0 is actually at pi over 2. Now tangent normally travels upward from left to right, but since we're dealing with the reciprocal of cotangent, it's traveling down from left to right. So here is our parent graph. This is considered one full cycle, one full motion, one full period. And let's go ahead and start graphing. We do not have a reflection. There's no negative out front, so we can immediately cross that off. Let's move on to our period. So originally, this graph starts at the origin with its first vertical asymptote and then travels all the way over to pi. But we need to stretch this ending point from pi over to 2 pi. Notice how we're essentially doubling it. It starts with a period of pi, but we're ending with 2 pi, which means we doubled it. So let's go ahead and double this vertical asymptote, which would eventually make it land on 2 pi. If we were to double pi over 2, that would just be a regular pi. Again, notice how this x or x-intercept is still in the middle, just like it would be on our original graph. So if we were to fill in our new graph with its new period, it would look something like that. Let's go ahead to our amplitude. Now, normally, remember the amplitude for tangent graph is we go halfway to the vertical asymptote, and this is considered our height. So I should have really drew this in a little bit better. Our line should be going through kind of that point right there. And I was a little bit better on this one. Halfway to the vertical asymptote, it should have a height of 1. So really, it should be going through those 2 points. But we don't really have a different amplitude, let's say of 2 or 3 or even a half. So we're going to cross out that amplitude. We're not moving up or down at all, so we can go ahead and cross that off. But we do need to shift everything to the left, pi over 4. Now if you look at your original coordinate system, pi over 4 is considered to be just 1 tick mark. So everything is going to be moving to the left 1 tick mark. So we can move over our asymptote. We can move over our point. We can't even move over these little amplitude points as well. And then finally, our last asymptote. So we will connect our dots. And there is our final cotangent graph. Now, since this is the final one, we should go ahead and repeat it over here, because after all, it's going to continue to the right and to the left forever and ever. So if we were to continue this image, okay, over here, it looks like this little amplitude point is 2 units away from the asymptote, so this one should be as well. We would have an x-intercept somewhere right there. We would have another amplitude point somewhere right there. And the asymptote is a little bit off our graph we could imagine it being somewhere right there. So if we go ahead and connect those points, we can have another period on our graph. Alright, moving on, last but not least, we're going to check out number 4, and it looks like we're going to end things with a cosecant graph. So let's go ahead and just go ahead and label amplitude, period, vertical shift, and phase shift. We don't have to do any factoring on this one because we don't really have a b value other than 1. So our amplitude is 3, our period for cosecant is 2 pi over 1, because with our little b value right there is 1. So really that's just the original 2 pi that it already has. Vertical shift, we're moving up 1, and phase shift, we're moving left pi. So let's go ahead and plot our original. Cosecant has a vertical asymptote at the origin, and then another one at pi, and we have a minimum at pi over 2, and a U-shape going up. Now you could graph the kind of upside down U either to the right or to the left, up to you. Since this one is already to the right side, I might graph the one over here, just so my original graph is somewhere in the middle of my coordinate system. But again, it does not matter where you plot it. So here's the other piece of our cosecant graph, and this is considered one full period. So let's go ahead and go through our little list here. No reflection, so we can cross that off. The period is not different from its original period. Okay, cosecant originally had a period of 2 pi. That's what it currently is now, so we don't have to stretch it to the left or to the right at all. It still has the same period. We do have a new amplitude though, an amplitude of 3. So instead of having a height of 1 from that baseline x-axis, it should have a height of 3. So 1, 2, 3, somewhere right there. And we're traveling up. This one should have a height of 3 going downward. So we can fill in that piece as well. So there goes our amplitude. Moving, it looks like up 1. So this guy is going to be right on the edge of our graph, but we still have that piece traveling upward. And if we move this piece up, somewhere right there, so notice how that kind of shifts our baseline up 1 as well. So instead of having that baseline at the x-axis, the baseline should be somewhere at 1 right now. Because if we're shifting our entire graph up, the baseline moves with it. Notice how from the baseline we still have a height of 3. And if we were to measure this one as well, we still have that height of 3. So if we move the graph up at all or down at all, the baseline still moves with it. So we can cross that off. And finally, left pi. So if we look at our original coordinate system, it looks like pi is a distance of 4 spaces. So we want to move everything to the left 4 spaces. So this asymptote that we really didn't have to move should be now moved to the left 4 spaces. So it's at the y-axis. This dot right here should be moved to the left 4 spaces. The other black asymptote, if we move it to the left 4 spaces, would be somewhere right here. This, let's see, we're dealing with the red graph. So this guy right here moved to the 4 spaces to the left, would be somewhere right there. And the black asymptote moved 4 spaces to the left, somewhere right there. So if we were to fill in the shape of our graph, it looks something like that. Now since this is our final graph, we really should fill it in over here, so let's go ahead and do that. So this green image is going to repeat itself over here, so that means we're going to have a minimum and another vertical asymptote that looks like this. And lastly, we should have a point right here with our U-shape going up, and another vertical asymptote right there. So that's about it for these reciprocal graphs. They act just like the original cosine, sine, and tangent, so I hopefully don't see this really being a problem since we're already starting to be masters of graphing these trig functions. So good luck on the practice, the application, and that mastery check, and I'll see you guys later.